Welcome to the second day of the Fab Lab. My name is Kelly O'Brien. I'm an assistant professor at the University of Dallas and the coordinator of the Fab Lab here at NCCA. This is the third year of a 3-year project, which is a collaboration between West Virginia University and NCCA. I'd like to thank West Virginia University, Brackers, Clay, and Scott for their support of this event. And of course, all of our presenters. And I'd like to invite you all to check out the work in the atrium on the pedestals there, which is a result of some of the collaborations that have happened as our presenters have gotten ready for these presentations. So this morning, I'd like to introduce MacArthur Freeman and John Bird. MacArthur Freeman is a visual artist whose work combines 3 interrelated emerging technologies: digital sculpting, 3D scanning, and 3D printing. His work, which explores racial socialization, employs hybrid digital and traditional processes. MacArthur is an assistant professor at the University of South Florida, where he teaches animation and digital modeling. John Bird is a sculptor working in clay, taxidermy, cast plastic, and other media. His visual language is that of autonomous decorative art objects, such as figurines, trophies, and souvenirs. As a reflection of his own upbringing, he's drawn to the challenge of taking disparate materials and cultural references that, when submitted to finely crafted and obsessive dedication, can exceed the assumed limits of either its media or class. John is an associate professor at the University of South Florida, where he teaches sculpture and extended media. Using a collection of digital technologies, MacArthur and John are developing hybrid sculptural objects that merge aspects of their current works. In particular, collaborative sculpting in virtual reality, 3D scanning, clay modeling, and digital fabrication provide a space for experimentation through digital combinations and remixing. Their emphasis is on play and generating a range of digital objects as an approach for pre-visualization of new works. I give you MacArthur and John. Thank you.
Back to the Fab Lab and having us this year that we're working on this collaboration. It's just really great to see how everyone's combining digital technology with clay in their studio practice. The name of our presentation is Digital Hybrids in the Virtual Sandbox, and it's pretty open-ended, and which really means we weren't really sure what we were going to do. We really wanted to create an opportunity to explore a range of technologies that we've acquired and have been working with, like 3D printing, CNC routing, 3D scanning, VR, sculpting, mold making, hand modeling, and a few other approaches all together and really see where it would take us. But our goal was really to collaborate through play and experimentation. So my work is more rooted in digital production, and John has more of a history with clay and hand sculpting. However, there are a few interesting places where our work overlaps, which we felt would be good for our collaboration. So first, I'll show a few of my images and give some background on my works, and then John will talk a little bit about his as well. So my background, I've kind of come, it's sort of a strange trajectory to kind of get to this point. My background is really, or at least initially, I studied drawing and painting. And I later went back to study, after teaching a few years and making work mainly sort of in that area, 2D based, I went back to school to study animation and digital modeling, or animation and new media. And one of the things that led me to do that was an interest in creating physical objects. I was creating a series of toys that I was interested in, and that's what got me started in that direction. But my works currently are primarily sculptural. I hadn't had much experience with traditional sculpting, but I started working in digital modeling programs like Maya and digital sculpting software like ZBrush and several others. So I've come to sculpture from this alternate path with digital tools versus traditional or analog sculpting. And these are some of my first 3D prints from digital sculptures. So these are printed on a Z-Corp printer, so it's the gypsum-based. That's basically the same material that's in plaster. And I've created a series of portraits like this. There were sort of 8 sculptures in the group, and I've always had this interest in the figure. My works were always narrative from the paintings and so forth. And I was creating a series of costume figures that became sort of mutations of, those parts became mutations and eventually became the figures themselves. And I started to play more with those forms. And it's been sort of this blend between abstraction and figuration. There's more, I can talk about that, but I'm going to kind of, I'm going to go through a lot of, we have a lot of slides, so I'm going to briefly go through them. But here you can see several of my initial drawings that start these works and then playing with them and, through digital sculpting. I often start with drawings, and I'll create maybe a range of them. I call it speculative drawings, where I may create as many as 100 drawings and then choose somewhere between 10 or 5 from those to work with more, whether it's drawing on paper like this or drawing digitally in Photoshop, and sometimes I'll show those as well. The main software and hardware that I use is ZBrush for sculpting most of my works, and I work on a Cintiq, so it's just a screen that's pressure sensitive. You can also have an independent tablet that's pressure sensitive like this as well, where you can push and pull the surface. The harder you press on it, the more impact it'll have on the surface, or a smaller or larger stroke. Which really also came from working with digital painting before. So it was an interesting, or at least it was an easy progression from one to the other, from working two-dimensionally on the Wacom tablet to sculpting. So these are a few of my works. This one is called Pineapple. It's bronze with a steel base here. Balloon bump. This is cast in resin. Each of these is roughly about the main forms are about 9 inches tall. The steel bases lift them up a little bit more than that, but they include orifices, sacs, appendages as part of the work. But they're not specific to actual forms in real life. And I'm really often playing between beauty, what's beautiful, grotesque, sensual, and humorous with these. And each one sort of references the body without being specific to a particular form. This is column, thin line, and these are 2 renderings that are still digital. I have actually created these through 3D printing, and one of these by CNC Routing, but these are just images, digitally rendered images on screen. So, and John.
All right. Okay, so yeah, I come again kind of the complete different direction from MacArthur. In my work, I'm typically been interested kind of in the age of porcelain figurature coming out of Europe in the 18th century, early days of Dresden porcelain, when there was a lot of kind of liabilities with the material, which there still are, but the value of porcelain at that time was such that things like cracks, I wouldn't say they were inherently overlooked, but they were kind of a consequence of this otherwise kind of incredibly valuable material. So I like, working within a set of limitations and trying to kind of push those, but like cracks aren't a problem for me. Yeah, it's fine. Looking at a lot of figurines, things talking about animals, a little bit of push-pull, things between anatomical models and figurines, but things that are a little bit off, some parts that are highly detailed, others that are not. You can hit that. A lot of times the work involves some taxidermy. In this case, there's a canary head in the back of this bobcat's head. But in a lot of cases, the pieces have kind of I wouldn't call it a front and a back, but there's one side that it tends to have a lot of detail, and another side that tends to be relatively shorn of detail to suggest that there's a back, and a lot of times much more physically kind of controlled and assembled. That's good, yeah. That's good. You can keep it short. That's fine. So I like to play with different kind of values with regards to cultural associations as well as like materials. And so in this case, this was a porcelain that's actually been polished. And what I like about it is that it's kind of a somewhat elegant surface. It looks a little bit like ivory, but also looks a bit like plastic. So to me, there's less of a kind of contextual association with it. It's kind of an in-between place. It could be either. And in a lot of cases, and we'll address this when we talk about working within the other software, but a lot of my work, and arguably the content is based on the fact that it's relatively labor-intensive, right? Sweat equity. maybe to the work's detriment in some cases. Yeah, let's go ahead. We'll come back to that one because it relates to something we'll talk about in a little bit. But again, decorative objects, taxidermy. Yeah, next one. There we go, detail. But things like chains, I call this like Florida chain, that kind of flat pack. We're all a bit culturally shocked when we relocate to Florida. And so chains, but again, high culture, low culture, things kind of mixed together. On one hand, somewhat elegant, on the other hand, somewhat crass, and trying to kind of merge these things. Next one. And then more recently, these are some larger scale pots, which don't really fit in with the work those other pieces, but relates more to some of the things that we're looking at here in a little bit. So there we go.
So, so when we thought of the virtual sandbox, we were really thinking of a large group of tools to work with, things like I said, 3D scanning, polygonal modeling, and I've mentioned some of these. But one that was really, that we definitely wanted to touch on was VR sculpting, which was last year when I was at the Fab Lab, I was really just starting to work with it. And actually, since then, I haven't gotten to explore it as much as I'd like. I kind of had to kind of pick it up again, which has been great. And one of the things that that it's offered is in the main sculpting application that I use, which is called Medium. It has a feature which is called Studio Share, which allows us to be able to collaboratively sculpt in the same space. So potentially, John could actually be anywhere. And we could continue to work together on the same piece. So and talk in that space. So of course we were using CNC routing, working with mold making, slip casting. There was one thing, and I had mentioned, or this mentioned in the abstract for this, where it's talking about virtual glazing. And I'm mentioning it here because it's something that we started exploring. But we stopped and kind of went in a different direction. But I do think it's a fascinating way of working. It's with a software called Substance Designer, which is from Allegorithmic, which creates material surfaces that have depth and they're actually just is used in games a lot, but also architecture to create three-dimensional surfaces. It's a little bit hard to explain now, but they're 2D. But they have a great illusion of sort of 3D forms. So this was our sandbox. We were looking at 3D, looking at some of the 3D printing we were doing. So for instance, this is SLA print from a Form 2 3D printer that I was using for my work, but it's limited in scale. So on my 3D printer, this is probably as large as I can get in there, but and I'll often combine pieces to get something up to maybe 9 inches tall or something. But on the CNC router, we're able to create much larger works. And this is where we kind of started with that. We got a new CNC router and started to work with it. The choice to, or at least one of the things that got me and John working together is there was a course that we team taught called Toys, which was a hybrid sculpting course, which part of it was digital, or half of it was digital and half of it was traditional. And it was interesting because a lot of the students who were taking digital modeling or who were in animation had not worked with clay. A lot of the students who were in ceramics had not worked digitally, but there was this time for them to sort of cross-fertilize. And some of them hadn't worked in either, which was interesting as well, and to see where they went with that. Yeah. So the main software we were using for that was ZBrush. And when I say digital sculpting, it's this way of allowing you to sort of organically push and pull forms. It's much different than working in something like Rhino or Maya, in the sense that it's brush-based. You have an area of influence, and it has often millions of polygons versus millions of polygons to create more resolution and push and pull the surface. And like I mentioned, you use a pressure-sensitive tablet for it. So in that Toys course, each student was working this way. They were also working in clay. We made molds. We did 3D scanning using photogrammetry as well. And And then the students worked together to create this collaborative piece, which was a hybrid, which was basically like an exquisite corpse. So you want to talk a little bit about it?
No, I mean, I think you've covered pretty much everything. I'll add something in a minute. Go ahead.
Okay. So it was basically like an exquisite corpse where the students were working. That's fine. The students were working. The students were working in clay first to build. Well, actually, the students half of the semester, well, part of the semester, students were working in clay, then digital, and then they chose what material they would work with to start making the parts for this. Everybody was assigned a body part. I think there were two other requirements. One was, well, it was the body part. There was a type of toy, and then there was some other conceptual component of it that it had to. For instance, I think one had to deal with sort of something that was domestic.
Right.
But they changed for each one. So the students working in clay, they would scan that work, and students working digitally, of course, they could just start there, and then they had to figure out how it would all be assembled together. So together they made 3 of these. So I guess that's 5. Maybe some people had more parts. I'm not sure, but and then the final forms were 3D printed, about 18 inches tall, a piece, and these were all made on a MakerBot 3D printer. And printed in PLA. So the start for this, the first thing that we wanted to do is just really get into VR. And the first day of it.
Yes, I'm gonna try not to.
No.
Not yet. Oh, too soon. Sorry, guys.
Too soon. So the VR. So the VR. When we started working with VR, I guess this is John on day 1. So he has Oculus face. That actually usually you'll see this marking around the eyes where you have the headset on. Okay, I'll get off of these. So
he's got a nice file photo, like pose, like yeah.
So well, it has this sci-fi feel to it. So and it's often hard to convey what it's like to work in virtual space. So I have this example, which kind of gives you a look into it. We'll actually demo it in a second too. But often when often when sculpting from the outside, people just see you sort of moving, almost like you're shadow boxing or something, working in midair. But what you're seeing is actually that object in front of you. And it's, it has depths. You can go around the other side of the object. You can lift it up and look underneath. You can scale it up to be able to see it better, or make it smaller so that it's in the palm of your hand. So it has this really sort of direct. Well, first of all, just the way you're able to visualize form is very, very different in this space than working on a flat screen. And you're using your hands. It has touch controllers. 2 of them are up here. Touch controllers that allow you to sort of push and pull those forms, add to them, cut off, paint, smooth out surfaces, and it's a really great it's a really great tool, I think, for sort of quickly blocking out forms, and that was one of the things that sort of attracted me to it, this sort of way to sketch in three-dimensional space, which was more of a bridge to working traditionally in some ways, at least for me to sort of think in that space, but practice. Because even working on 2D screen, there's a little bit of a disconnect in terms of visualizing those forms, especially when they're really subtle.
And while this illustration is great, the one MacArthur put together, but it's really hard to convey kind of the experience of being in it, because you're essentially you're literally in a gravity-free environment, and then you have this object that you can essentially create. Again, you scale up, scale down. We'll talk a little bit more about this, but it's kind of, and again, I will say this, I did not come to this with any, I wouldn't say, I don't have a lack of interest in digital technology, because that's not true, but I have a lack of interest in getting away from the qualities of my hand and my hand making. And that's what a lot of the digital technologies I felt, that's kind of my resistance, is I didn't want to kind of lose that. And so this is immediately with MacArthur, he's been doing this research for a while, but immediately once he got me in there, I was like, oh, wow. I mean, I get it in a way that I didn't kind of understand it, right? And I talk a little bit about in my work the kind of inherent vulnerabilities of working in things like porcelain and sculpting and form and slumping and things that we think about kind of in the practical world of creating. And then in this place, again, in the VR, there's no gravity, right? Limitations are completely different. But it does have its limitations and liabilities. They're just, a bit different right there. And again, we'll get back to this some, but and for me too, it's like, and I present it to you not necessarily as a way to kick out finished products, which is what we've done here, but it's an amazing space in which to think about like ideation and ideas, sketchbooks. I could run through more ideas of thrown and altered pots in here in about 20 minutes than I could do in a day on an actual wheel, right? And I may have no real notion of actually wanting to produce anything in this experience, but again, I can work through Sketchbook in a way that's literally three-dimensional, right? And it's pretty interesting.
Yeah, and actually is another point, even in terms of thinking about it as a sketchbook, when you save a file, it's actually in this window, so you can kind of see the series of models that you've created. Really easy to kind of scroll through them back a year or so in the past and kind of check them out too. So this is John actually working on the first.
That's me looking into a pit of technology despair. You can see. It's like, what is this? That's probably my first day on here, wasn't it? I think it was, right?
First day.
Okay.
So.
He's a smart one on the stage, incidentally. You'll see that pretty quick.
So here, this is both of us in the working in the riff. So he started working with the pots. I was creating more this like vignette, and one of the things I was using was stamps. So there are sort of pre-made objects that you have in there. Actually, I guess there's nothing pre-made there. I added them later, but just to be able to work in the same space, and I guess this is the beginning and trying to see where we're going to go with it. For me, I wasn't. For the works that I was doing, I really felt like working with like digital sculpting and ZBrush was the thing that allowed me to. Well, it was the main way for me to make my work. So a lot of times when I was sketching the Oculus Rift, I was really sort of practicing anatomy and studying in that way. So I started out making heads. Not necessarily knowing what to do with it, but I was thinking about the fact that this sort of connection with anatomy and sort of organic forms with John as well. And often I would break things down into pieces, which was a much easier way to work than sort of pushing and pulling the surface, actually just adding parts on and then merging them into the surface. So this is another one of the pots that you were making in, early on. And the good thing was that oftentimes I would look over at what John was doing, because I think a lot of times he would be thinking, okay, well, this is, I'm just starting at this, but I would look over and see something he's doing, and because he's kind of coming at it from a different perspective, I would think, oh, that's really cool, and then I would steal it. Yeah. And then we might kind of go back and forth and with that a little bit. So one of the things I looked over at is when you were kind of working on this. So this is one of the stamps.
Right.
And then in your actual sculptures, you often have these sort of pockets and cavities where you're working with form.
So he says stamps. In the program, you can construct forms that then you can make a mark-making tool. So it could be anything from a tool with which to carve. It could be a form. In this case, if a rabbit was a stamp. Sometimes I could use them and make tools that were almost like ribs that I could use to almost lathe other forms and things like that. So.
And even this idea of sort of coming to it and thinking about it like clay.
That may be one of because I'm definitely coming at this kind of bass-ackwards in a way. And so my initial tendency is always to try and create a situation that's not dissimilar from what my experience with clay is. So I try to use tools the same way, even though, of course, they're just like virtual tools. Sometimes it works well, or it leaves a different mark, obviously. But I don't think it's, I think it's a different way. Yeah, just an interesting way to come about it, maybe. Sometimes I get results that are interesting in ways that I hadn't expected.
So as we talked more about, so all along we were kind of thinking, okay, what direction will we kind of move in this? And I think one of the things that kind of stood out was this idea of working with figures. We both had, we kind of relative to it, but we hadn't necessarily been working with actual figures in our work. and it seemed like a middle ground in some ways, and playing with anatomy, and also cavities in these pieces. So this is one of the pieces that I started making from that. The skeleton that you see underneath is actually a stamp that was in Oculus. I started building over that. But then it allowed me to kind of carve out spaces as well, so delete parts as I was building. You can bring in images. So this is something that's more similar to the sculptures that I make. I brought in some sketches that I was working on and then started to build that onto the figure as well. And this is one of yours.
Mm-hmm. In that case, yeah, I was building on with particular types of obstructions. So in this case, limiting myself to which tools I could use in terms of creating that. So kind of regulating my formal decision making in some ways, just as an experiment.
So one of the things that, one of the first ways I really started working in the riff was really to I kind of was thinking about like how I might add pellets to a surface in clay to kind of build up the form and push and pull it. Because it's a little bit more difficult to control the surface because you have no resistance. So when you want to make that form, it's always additive as you're adding like more mass onto it. So I started doing that, but which works well between sort of adding and then smoothing out to be able to create subtle forms, but it's a very slow process. So one of the things I really started doing is actually just making more simplified forms. And sort of push and pulling them. I think when I started working this and then when I presented before, it didn't have a move tool, something that you can grab and sort of stretch the parts with, stretch forms with, which has been a really great help. And it's actually kind of transformed, I think, what's possible in sculpting in it. So here's some of the sketches, and then maybe one of those simplified forms. But then from that, looking at it, we started making stamps. And just small bits and pieces of things that were just that had an overall feel, but I had no sense of necessarily how I want to use them, and creating sort of a library of them. These are sort of two different directions from that. One are really more complex stamps that I'm sort of putting together, and then sort of really simplified ones where I'm building this structure.
I'll probably talk more about that once I get on there. Yeah.
So that was our sort of initial work in there, and because we knew we wanted to work with the body, and we also wanted to explore the technology, we decided to 3D scan a body to use as a starting point, a blank in some ways. And so this is Chuck. He
should be here. It's really unfortunate. He couldn't make it to Antigua this year, but yeah, he's their trusty technician and my right-hand man.
So we got him to do this, so to model for us, and I picked the pose and everything.
This is the clothed one, by the way.
Yeah. Okay. So we're using an Artec Eva to scan here. It's a handheld scanner that, and basically I have to hold it. It's kind of heavy. It's holding the computer like this to be able to walk around him. But it captures really, really well, especially objects at this size or medium size to larger. And this is the initial import. This is what it built. So I was really focusing on the torso. I was thinking more, we were both thinking about this idea of more like these anatomical models. So initially we were thinking we weren't going to use the head or legs or anything like that. So it was more the torso. We did actually start using parts of the head. So there are holes there. And it also doesn't scan hair well, of course. It's really fine, but then also the dark values are very different for it to capture as well. So from that, we went back into VR, and this is another. So this is slowed down. Well, this is real time. of John sort of sculpting in VR on a pot, kind of exploring some ideas there. The next one is sped up, so you can kind of see a range of things that we were working with in that space.
That's how fast I actually work now. I'm just trying to look
So,
cool at this point. I don't even know. Yeah.
So yeah, you can kind of see me looking back at the camera, making sure that everything's. So you actually have there's a virtual camera that's in the space that you can move around. Actually, maybe you should.
I'm the good-looking one here, obviously. But the notion that you can, so in this particular case, yeah, you can import objects, photos in. So looking at some Chinese vases. In this case, I am building, again, a stamp, but I'm using this stamp essentially as, and this is just one strategy I was trying to mess around with, but using it kind of as a rib of sorts that I could use to kind of lathe forms. And so in this case, then essentially, now I have applied that stamp. I am using it to erase material. And then just really kind of playing and seeing what works and what doesn't. Again, talk about qualities of the hand, and again, it's weird to say qualities of the hand because my hand's not there, but it does react directly to what my hand is doing, out here. Sometimes, and so it's I think that's what we're all trying to kind of figure out is what is the kind of language of digital making, right? And this is my way of trying to sort it out, especially based on my history of being kind of a hand maker.
I was just jealous of your hair. That's all.
Yeah, it's pretty good. I'm not gonna lie. Wish I actually had that. So here we have, yes, imported that model back in, and so we're working on variations of it at the same time. But again, the kind of beauty of this kind of collaborative working is that, as you said, you could be anywhere. You could work with someone anywhere in the world who essentially has access, right? There's no real, assuming you've got, the quality internet, so you can port right in there.
So from these, we started, like I said, using that body as a starting point. We started to generate several of these, partially where we had these. They were either as if they were internal organs or something sort of referencing internal organs that were coming out of the bodies, or like cutting away from the bodies to show them, and also even looking at platforms. Because you use those quite a bit in your work. Putting here, I guess I've sort of placed the body inside another body. I think one of the interesting things to me was starting to use these stamps to build up patterns. So you can see in the figure, well, I guess it's in both figures, you can see this repeating pattern going up. But that was separate from the figure. But what you can do is you can actually do an intersection. So you can have one pattern, and then you can use the body to subtract. Well, not subtract, and do an intersection where both areas are overlapping. So on this form, I was able to combine those two pieces to create this sort of ribbed internal form. Here is probably a better example of that. So there's the figure. There are these separate little pieces that almost look like, I guess they almost look like pots, but then being able to get the intersection so that not anything that's outside of it is deleted, outside of those two parts. Or just Boolean operations where you subtract one section from another, which was really helpful, like on the figure on the right where it's inset, being able to go in and sort of carve that out, and then using stamps to build into that surface. Even the pipe-like tube that comes on the outside of it, we were able to use an intersection, or at least use one of those intersections to be able to clip those off. So out of this one, initially this figure was, I guess we started thinking about meat. So this figure is called Meat Man. It was renamed to the final piece, which is
Beefcake.
Beefcake, yeah. And because of that, I think from that name, that's where the sausages on the side came from, and the other parts coming out of the head, in different places. And really just playing, experimenting in that space.
I mean, again, I can't kind of overstate its, even if I have no interest in, again, pulling out, using these 3D files to actually, or digital files to actually produce things in 3D, I can't overstate its potential kind of for sketching and figuring out ideas. I mean, I'm not a big sketcher before. I do some sketching before I work, typically with regards to proportions and things like that, so I can relate, the scale and everything. But again, being in this space and being, I'm the type that I can't really get a sense of it until I see it, right? In this space, I can get a much better sense of it. And so simply the notion of working through ideas in this space, again, if I'm going to come out there and just build a traditional armature and build on it, it still has a lot of value to me.
And even just the idea of scale, to be able to think about something that you're going to be, if you want to build something that is your height, you can actually create something that's literally that height in the space and walk around it and get a sense of it. Yeah, or larger. You can make it
larger
monumental.
And walk through it. I mean, that's the thing. Yeah,
So we settled on, from different studies, we kind of settled on this form to actually be able to make, which was important. We were kind of...
we were pushing to the end, which we'll talk about, because I tend to be last minute at everything, but I don't need time to be creative. I need a tight deadline.
So from that, right in the software, it allows you to export it out. You can export out as OBJ files, which will pretty much go into any 3D modeling package, or most 3D modeling packages, and or an FBX. So we exported these as FBX files. I brought them into ZBrush. This is not ZBrush. This is actually Mesh Mixture. What I use it for was to find, after doing a little bit of cleanup in ZBrush, it was to find areas where there are errors in the mesh. It's really, using Mesh Mixer is really good for that, filling holes, but also finding errors in the mesh. ZBrush does a great job of filling holes, but the error part detection is not there. So you can see all the little sections in red. Those were places that needed to be repaired. And this was really more of a test. I think in our final model, we actually didn't have to do that type of cleanup. So what we wanted to do is to be able to do a two-part mold for it. So we need a parting plane for the figure. And I had done something like this before. I had worked with, I took a class with Del Haro, who's really great with doing this sort of digital mold making, and actually just, I think his work's really interesting. But I wanted to try out approaching this from ZBrush. It had been a while since I had used Rhino, and I was looking at this as an approach. So one of the things that you can do is you can select groups of surfaces based off of their direction. So if we look at this from this front purple image, I kind of rotated it and said, okay, well, I'm just gonna turn everything that's forward facing into a group, and it actually does it by angle. And you'll notice, for instance, in this next image here, that there were still some problems with that. The one on the left here, you can see that there are still these undercuts where it's facing slightly in the other direction. So it's actually still facing away from us, but it's on the back side of the figure. So those things had to be consolidated. I had to go back through and group them, which I did here. It's not a smooth line, but it will be smooth enough to be able to create that parting line. This is the same idea as just from the front view. The one that has those additional undercuts on the front, and then ones where it's cleaned up. So what I did like ZBrush for with working with this was actually to just, so usually I use it to sculpt, but in this case it was more of a tool to sort of prepare it for 3D printing or CNC routing, which is great for. And we were able to slice parts off of the figure really simply. And then to be able to start to create the parting plane. Now, as soon as I started creating the parting plane, and this probably would have worked, but then at that point I realized, you know what, Rhino is way faster at this. It has tools that are set in there, and I'm glad that we switched, because even just to be able to deal with, be able to take measurements, accurate measurements in there was really important. later on, because here it's just a little bit messy, and I would have to do a lot more work to clean this up. But the process was more straightforward in Rhino. So we switched. But for ZBrush, it was great to be able to kind of colorize this, break it into pieces, so you can see how just slice it up, close the holes for it to be able to bring to the next stage.
Well, I guess I will say quickly that we've heard different universities kind of have different philosophies with regards to software and hardwares that they use. And we do feature some freeware and shareware, but but we kind of also believe in, and MacArthur's reasoning, and I think I agree with it. We really want to prepare our students kind of with the highest, most extensive end, so that we try to remove all limitations with regards to software. And so using some, again, not necessarily freeware, but my feeling also is that in learning some of these more high-end things, that it's easier to convert down to some of that freeware if it is necessary.
Yeah, the best tool for the job that is the most affordable. I mean, somewhere in there. I mean, so for instance, like Mesh Mixer is a free software. I mean, it doesn't make sense for me, it doesn't make sense to actually go for something that's way over that. ZBrush has some really helpful tools, I mean, that you can't get anywhere else, and it's worth it for that. It's probably one of my main tools. And actually, one of the ways that we were exploring using this was even to just that we had talked about, but was using it to decimate and create more sort of contrast, these really natural or organic forms, maybe even from the scanning or whether sculpted, and then faceting them. So in ZBrush, it's really easy to be able to decimate and change it. So you can and shift from one to the other, and it's really immediate. To be able to get something that's really low res to something that is high res. Some other things we were looking at were cameos and low relief, which is we were able to use grayscale alphas. So for instance, right here, you can take a model. So this was that original 3D model that we saw before, and you can capture that. Capture its depth on screen so that it becomes a grayscale image like this. Once you have it in that format, there's a lot of ways that you can sort of use that. Even in the CNC Router software that we use, we could actually just bring in this grayscale image and actually have a relief just from that, or be able to combine multiple images like this to create a really complex relief form, which is something that I think I'd really like to explore further. I think one of the last pieces that we kind of created from this was this.
Yeah, it was just a weird pot. I was looking at some Chinese gourd type pots and taking the top of it and then making a stamp and adding it, making it taller. But again, that for me, just the experience of working in a much more kind of, hand way, and then the notion of printing that out or cutting that back out. So.
And this also sort of allowed a different type of mold. So for instance, for this one, it's really, we could actually just use a flat plane to cut it. I mentioned, well, first of all, this Rhino. So Rhino and Del Hero's sort of approach to creating parting planes for these. And this is online. If you go to dataclay.org, he has a sort of a reference there that you can download that's really helpful for doing that. And this sort of contra mold process, contra mold machining, where you machine out, I guess, sort of a positive of the form, but sort of a positive of the form, sort of built into the.
They call it a contra mold. I call it a mold.
So.
I think that makes sense, right? A mold.
A mold's mold.
A mold.
A mold's mold.
So as illustrated.
So one of the things about Rhino, you can bring it in, and immediately the first thing we were able to do is there's a feature called draft analysis. So on that we can actually see where all of the front facing, well, basically so that anything that's facing more than 90 degrees away is shifted in color. So you can see this blue on one side, red on the other, and this sort of intermediate area is green. So from that, you can generate, and this is why I liked it much more, from that you can immediately generate a curve based off the draft analysis. So then in terms of the parting plane, you don't necessarily, let me go back, you don't necessarily have to draw that in manually. Now you will have to fix some things because there are places where that line may overlap itself. in the model. So it's hard, if I could zoom in, I could probably show it. But there are places like right after this little. I can't point to it though. But there are places in there where it'll overlap. So one of the ways that we sort of dealt with that was to simplify that line, because it doesn't necessarily need to be a really high-res line, and then it's much easier to go in and delete points off of that line. You can see the little sections on there. And then here's more of a cleaned up version. It's still on the flat edges, there are a few things to clean up, and then we can get this final sort of vector line, and it's not flat along a single plane. So our approach was to go in and we create two offsets. One that goes sort of inside the model to make sure it completely connects, and then one on the outside of the model, which actually kind of creates a sort of area of relief, I think, before it starts to reach up to the outer edges of the mold. So here we have so here's the flat plane, which would represent the outside edge of the parting plane. Here it's flat, but in the next section you can kind of see where those points have been, a duplicate of that has been adjusted so that it follows more of the shape of the parting plane, and then generating it. Now here, this one is not a good version of that, mainly because you have some places again where as it rounds a curve on the form, it's sort of falling back on itself. So by actually lofting these edges in parts, allowed us to be able to control where the direction of the connecting points to the connecting parts of the parting edge to the outside. So here's our first sort of breakdown of everything there. And the great thing about this is that when we were for CNC routing, we could actually just turn the model over, and we have the back side. And it's that same parting plane. And the fact that because the surface is modulated, you don't necessarily need keys to lock it in. And like I said, another great reason for using Rhino for this was just to be able to take measurements and be able to put these directly into Aspire.
Aspire is the software that our CNC uses.
Yeah, or at least that creates the tool paths for it. So you have this one. You have all of the parts for it. This is just sort of a flat one for the pot, and then you can see how all of the keys are made, and then the cameo.
I was going to show the. So that would be this, yeah. All right, these. Mold.
The mold.
Mold.
Okay. So from that, we use a software called Aspire, which actually creates toolpaths. It tells the CNC router. So we're familiar with 3D printers, which sort of build up in layers. The CNC router carves away in layers from a block of material, but it needs a toolpath to be able to trace along. So by putting it in Aspire, that's where we'll develop the toolpaths for that. And it's a pretty straightforward process, especially if you have a three-dimensional form like this. So sometimes you may have to do more if you have to follow a particular vector line. But what it's just doing is just looking at the surface, almost like a grayscale, and figuring and creating the depth passes from that. So actually bringing it in, you can see this is really subtle, but like from this one here, you can see the step over, the lines that are in the surface as the bit goes over it. It creates a ridge. This is a smoother version of that. And here we actually have a generated toolpath. This is pretty dense for this one. We simplified it later on. But the great thing about this is you can get in, you can figure out exactly how long it's going to take. A big issue that we had to deal with was the size or the depth that we were trying to get. Because we wanted the figures to be a certain size, but in our CNC router has about a distance of 7 inches of clearance, which I was thinking, oh well, that's great. But the issue is that if you have a tool that's 4 inches, then you can't and you have 3-inch material, you can't even get over it to cut into it. So our sort of middle ground was to have 3-inch material and a bit that reached 3 inches outside of the collet, which is the holder for the bit.
And we were a bit limitations with regard to tips that we could use in terms of the detail we could acquire. So those are cut with a 1/4 inch. Right, those are 1/4 inch ball nose, or do we have smaller?
1/4 inch ball nose was the one that worked in the end for the to get down.
And obviously they make finer tips with finer detail, but
yeah, but it's hard to find it. So I think we weren't able to find.
We have to get custom made, I think, honestly.
Yeah, we weren't able to find an eighth inch diameter one for the ball nose, and that was important because, for instance, in here, like if you look at this, there's that side where it actually goes really low into the surface, and what would happen is the bit would hit over on that side. So we rushed all over looking for bits, and someone laughed at you.
I know. Yeah, I asked them. Yeah, it was a specialty bit, and of course, I guess it wasn't typically used. But I mean, the issue is that a lot of this equipment is still primarily used in industry. And our machine, in particular, I would say, predominantly used in the furniture industry. Right? We have multiple machines, but this one in particular, which is a great machine. But then probably they're not used to people wanting the length and the detail that we're looking for.
It's mainly for flat goods and low relief. And so what we had to do, so one of the approaches for dealing with that was to actually cut around the areas around it so that we could get down a little bit lower. So this was sort of my way of trying to visualize the path on the side and how much I would carve away, and then stepping down and saying, okay, well, I need a line that's this far, and then I would cut it right before cutting out the model. And eventually, I think we just, and that actually did work for that. We were able to get a higher resolution for that one, but then eventually we just went to a larger bit to get the distance. And here are the sort of visualizations of these carved. They look like they're carved in. I mean, the preview here is as if it's carved in wood. And then CNC routing. So this is our router. It's a Cam Master, and one of the things. So we started out. We wanted 3-inch material, so we glued the material together.
I thought it was a genius idea.
So which we thought would work, but the thing was the glue. It would pick up the glue and it would clog it up, and it really messed up the surface.
Probably just the glue I use is a problem. But if we were fortunate, great thing about Florida is it's beautifully warm and sunny, especially. It's nice this time of year, but finding nice, thick insulation can be difficult. We just happened to find a distributor not too far from campus that had this 3-inch or 3-inch foam.
Oh yeah,
excellent. Yeah. So we are cutting into just regular Corning. Well, it's high density Corning insulation. I mean, it's not. A lot of you can probably find this depending on where you are. Probably the Pittsburgh Home Depot is going to have this. And they make higher end foams, obviously, some of which are going to have you a slightly better detail take. But we also, on this level, we kind of wanted to do it, experiment and try it on a little bit of the cheap. But yeah.
So, but it worked out. It worked out pretty well. I'd be interested in trying some other really dense foams.
But we are milling into this rather than just milling straight into plaster, which is another. Yeah. I mean, you've seen some people talk about doing that, which also is a possibility. So.
These are just these are our instructions. This is our manual of how to run the CNC.
Yeah, I don't understand any of this, by the way. I just want you to know.
So, and the machine cutting out each section here, you can kind of see how we have the rough pass and then a finish. We just did 2 passes, a roughing pass and a finishing pass. So you can see the larger bit and the larger step over, and then it's kind of going in for a more detailed version of it. And this is it running. So we don't have any sound in these. I mean, the CNC router, it's pretty loud in there. Mainly the vacuum is probably the loudest part, but even, I mentioned that also because even with the Oculus Rift, there are sound effects that kind of go along with it. That sound like, there's like the shaving cream sort of sound when you're adding material on, cutting things off. There's like a laser beam when you want to cut something off. So yeah, so this is sort of closer to getting to those final molds, the low relief. Both. This is me and John and my little helper who was making sure that no one messed with the foam.
Yeah, tough guy.
And then carving out the final pods there. So, and plaster molds.
There we go, soaping them up. I mean, so yeah, we've done a little experiment. I was a little concerned with release. I'd read some horror stories about getting these things off, but it worked pretty well. There are products that for coating, Styrocoat that Smooth On makes for coating these types of foams that won't eat the foam. I mean, that's another thing about working with this foam now, and of course the advancements in resins and binders and things like that are pretty amazing, because of course there are companies that make CNCs specifically for cutting foam, but they present foam as a way and then coating that foam to be essentially outdoor worthy sculpture, right? So then the styrofoam becomes a finished product. So, but there are materials, obviously the Styrocoat we could get to kind of seal that mold if necessary. I didn't want to put another layer that was going to obstruct any kind of detail, so we just experimented and the soap seemed to work fine. Just a very thick layer of soap. Yeah.
And I'll probably go through the rest quickly so we can get to the demo. So
don't show the mold. Yeah, skip the
oh
one.
Man, I wanted that one in there.
Plaster's leaking out, and my students very carefully trying to. Yeah.
Oh, I didn't put it in. It was the video.
Awesome.
It was the video of you saying you didn't want anybody to see it.
Yeah, don't show them that. I said.
So we had the plaster mold, and then final assembly here. The first pull.
Yeah, first pull. So we ended up the mold was, again last minute. Mold was pretty wet. Also, we were pushing the limits on a two-part mold with that. I mean, obviously, there was some kind of vertical side areas that honestly probably would have been better served in a three-parter. But also, I think my next step, anytime, would be to start putting airline in the plaster for helping to eject these parts, especially when we're doing that. Probably the easiest thing.
Is that clay?
Was that part?
You cast it?
Oh yes, we casting clay here. Yeah, so this is a porcelain casting slip. We ended up press molding. Really, the issue was that my mold was still too wet to really do a good slip casting. But it's going to press molding, popping it out. And again, let's talk a little about this. But this, where we're at right now, obviously, is that it's producing something that it's noticeably less detailed than either of our work, right? And the piece out there, I would say, certainly is. And I like the tool marks on there from the CNC, and you see some there. I don't have a pointer, but you can see some of the kind of tool marks. I like that, but I would like that probably in my own work ultimately with the contrast of really tightening it with a hand. I really like that contrast. But I could definitely foresee methods of making in which I'm actually just pulling out blanks with full intention of kind of hand working, right? And doing additions in that regard. But not expecting necessarily or needing to have that level of. I mean, we can cut to higher detail. There's not without question, and even pull molds to higher detail. I mean, I can't pull them to not can detail, but the point is, it can get, obviously there's not less limitations.
And a lot of it has to do with the softness of just the bit, but also the foam.
The foam, yeah.
Itself. And
there are other materials we can cut into, like MDF and things like that. I mean, in order to achieve some of these things. That's enough of that too. Yeah.
Okay, and then this is the final piece. In terms of the time, so the first time I actually did I see it here? Did you have it here when I actually saw the final?
I finished it about a couple of hours before I got on the plane to come here.
So maybe we can talk about these. Wow.
Yeah. Let me start up.
You're working. So after working together, I think there are just a few things that we're kind of looking at in terms of some of the reflections. The first was sort of just the hand and digital technology relationship, just this idea of working with the riff. It's this three-dimensional space. It's much more natural in that sense that you're able to.
Will you cut the sound if that's a problem? Because I can't.
Oh, the sound's not on.
Oh, okay.
So in some ways it's much more like working with physical in a more physical and traditional way. But I think at the same time, one of the things it misses is this sort of resistance. Like I said, it's much harder to sort of control because you don't have something to sort of push against and brace yourself. Also, I think a strange side effect for me when working. Can we switch? Oh, well, not yet. Let me know when you're ready. But a strange side effect for me when working, I get really, I think over time, working for a longer period of time, I actually start to kind of get tense, almost, because it's almost like I'm putting in this energy, but then there's like nothing to sort of push against to release in some way. It's
yeah,
like,
I mean, they've changed the software quite a bit and pretty regularly, which I think is interesting, because obviously the next step would be for this to be essentially haptic, where we can kind of feel that. But one thing I will say about this is that, I tend to be pretty ADD on my best day, as you maybe have noticed. But it's kind of an isolated space, so I find that I work in here for long periods of time, kind of without, the time passes incredibly fast sometimes. And again, it can just be sketching and working on ideas. Let me see. I can set up. You can switch it over anytime.
actually, that's a good point too. I think at the same time, I don't get distracted in there. I mean, you've just got that space. There's no Facebook. There's nothing else playing. I mean, you can have music in there if you want, but the thing is, you're in that space and sort of isolated, which does allow you to focus.
All right, so I am just missing. Obviously, we've talked about many different modes of kind of working. I should find a color that looks something like clay. Oh no, I should find a color that contrasts this a little bit better. Let's go with. Pink. That looks fabulous. So MacArthur, the space I work in, I actually have a floor and like a horizon. So this is MacArthur's setup, and it is. There's really no gravity in here. I'm going to try not to, make a YouTube video. Tripping over something is what I'm saying. But again, there's a series kind of tools that are available. Can you guys see that? It's hard to know what you guys can see on the screen. But so again, everything here for me is fully kind of three-dimensional. So you can see a variety. Tools for cutting, flattening, swirling, moving. Clay is what we're using, smoothing and inflating. But clay here. And again, this is not the only way of working, but this is one that kind of interested me because I thought it was really kind of reflective of the hand process. So I can bring in images from outside. I can use them. I can use them as references or to build with them. But I have essentially the program refers to this as a lathe. Make sure I have my setup here correct. Adding, erasing, continuous. All right, we're good there. All right. But I can just begin laying down, in this case, very pink clay. And so again, my hand's not in the material. But it is reflective of everything that my hand does on this outside space. But if you want it more kind of convincing for your mind, you can make a very convincing looking colored clay with which to work. Sorry, this is not a very beautiful pot, I'll be honest. And we're getting gigantic here already, aren't we? All right. But then immediately I can pull this right back down. And now I'm working on this thing, right? And of course, I need to let's carve a foot on there. Let's make it a little larger. Got to recenter it, we all have to do that, right? So I'm just laying down this material. So I don't know if you guys probably can't hear it. It sounds like shaving cream coming out of a can in my ears. But if I even want to have so then again, we have tools here. So in this selection of clay tools, I have a range of options here, different shapes, but then we have, MacArthur's mentioning these things called stamps. And so these are different shapes with whoops, let me do that again. Different shapes with which I can work. But we even have things here that would be kind of like traditional shapes, or i.e. trim tools. We'll call it that, all right? I can adjust exactly how I'm holding the tool. I can make it larger. The green indicates that I'm applying material. I hit this button twice, and now I'm removing material. I literally carve a foot in. I'm pretending you guys aren't even here anymore, by the way. Let's see here. All right, turn this back over. So I talked a little bit about this idea of, let me turn this off for a second, off. But this notion of then pretending with ideas of throwing and altering. Let's do layers first. Actually, I'm going to do cutting. And so I have this kind of laser line here, larger, and I can cut this in half. Renders it into another layer. I can then move this. Let me see here. let's try it like this. All right. Maybe overlap that a little bit. I can then subsequently merge those. I can also turn that into a singular stamp. All right. Turn that up. Now I can now I have this same piece of material. I don't know how well you guys can see that, but now I can duplicate that form. Let me see if I have a high enough res here to do this correctly. Right there, so I can begin to play like that. Begin to change this form up. This is not the file I'll give you, MacArthur, I promise. I'll give you something simpler. There are tools with which I can use to kind of soften things, and it's kind of a, it sounds like a little spray gun, but I can adjust the kind of thickness. The way that I apply, I can soften some of these edges. I don't know how well you guys can see those. But again, I can really play with scales. So in my world right here, I would say that this object is probably 24 inches across. But then I can instantly make this if I want to. Think about this. I got a public art piece or something you want to do. So now I'm looking at it. It's about 12 feet tall, right? Again, in my space, I have a floor, so I can set it down. But I can literally, I don't want to run to the table, but in theory, if my quote-unquote play space is large enough, as I can walk around it fully. I mean, right now I can turn it. That's without question. But I can literally walk through it. So thinking about, site-specific type of experiences, we could do that. So very quickly, how do you want me to go ahead and make a file and export it, or what would you prefer?
Yeah, actually, can you go to the, can you import an image?
Yes.
From anywhere, it doesn't matter where it is.
Yeah, absolutely. Let's go to here.
So you can import, maybe custom? Well, anywhere. Yeah, custom is fine.
So these are images so this is MacArthur's setup we're working with. These are images that he has imported in from his sketchbook.
Sketchbooks, figures, all kind of stuff that's in there. Yeah.
And so the ability to kind of work with these in your backdrop, so you can put lots of, and you can also work with palettes.
Oh yeah, color palettes.
As references. So again, in this nice gravity-free environment, they just kind of float.
Yeah. And maybe the library.
Oh yeah, okay.
Not that one. Is it the yellow button?
Yeah. Sorry, sorry for you asking. Yeah, okay. Yes.
No, it's the yellow.
Yes.
Yeah.
All right. Library. So then, and then forms that are stored on here, they can be then imported back in. Several variations of the figurative piece that we made. Is it big enough for you guys to see in there? Because it's like.
Yeah.
Okay. And then a whole history of objects. And you can also connect with other users and makers through this system. People will post their objects publicly.
Oh yeah.
Let's see. Let me go back out. All right.
Okay. Yeah. So any form that you want to bring in.
All right. I'm sorry. Okay. See, I still fumble with the controls, MacArthur's is so smooth at this, it's very impressive, I'll be honest.
We could use that. I mean,
you want to export it just for the sake of, okay. All right. So then from there, create a file. You're like, man, I love this thing, genius. It's a salt, pepper shaker, oil, and vinegar. It's amazing. But in terms of my application for this, so at University of South Florida, we are truly kind of we're a very interdisciplinary school, and kind of the trajectory of our dialogue is consistent with really kind of the conceptual levels of contemporary art. It tends to be very kind of stringent in that way. So we're not in a program that necessarily, we're a program of makers, but we're not necessarily one that fosters kind of like long traditions of craft history. Because we're looking more at kind of the history of contemporary art. That said, I begin to look at technologies like this and how they can feed into another practice. So for me, and it's just thinking about things like pots, and I used to make pots, maybe not all that well, but I like the idea of using this design process and thinking about other modes of manufacturing, like ram pressing and things like that. So we may not necessarily, be the pinnacle kind of pot making, but we might be able to be really good at this other kind of thing as well. Okay, so now we're going to go ahead and I'm going to export that. I need to save it first. All right. I'm going to export this out as an FBX file.
Yeah.
Good.
And turn off the OBJ.
Turn off the OBJ, yep, okay. And export.
Cool.
Cool, all right.
All right, so
You want to just shut that down from there?
yeah, I can do it. So we just have a few minutes, so we can probably
You can answer some questions
answer
while you're doing
questions,
that
yeah.
if you have any questions. Of course, the tech questions I've got, I'm just going to point at him. Yeah. Mr. Odgaard.
Did you bring the molds for the meat here?
I did not, unfortunately. He told me to. I should have. Sorry, I apologize. He wanted to, and I was like, no, we don't need that. Should have known Odgaard would ask for it.
Where am I going? Let's see.
Yeah, it's interesting. Like, yeah, I would, that's why I started to wonder about the level of detail that I need for it to be. But I know we can cut tighter, and we can definitely cut tighter in other materials for sure. We do have another CNC that has a higher vertical clearance, and so we might kind of get that set up. The other one we're using is kind of it's creme de la creme. Also, I will add that I don't know that much about this technology. I mean, it's all pretty new to me. So I fumbled through it, and thankfully, MacArthur, I'm riding his coattails into this thing today, and but it's been good to learn. And I have ways to go though. But I would argue, I really feel like the technology the technology's got to get a little bit better, and it will. I don't know that all students have to be experts at this, right? I would bet we're 5 to 10 years away from there being essentially, well, the problem is, of course, I can make this thing an Oculus medium, but then we've got to go, he's going to run it through Rhino, and then we're going to convert that to Aspire, then that's going to go through the CNC. And I mean, obviously, it'd be really great if we're at a place where I could just go directly from, the Oculus medium into the CNC. And I don't think we're that far from that being capable. That said, I kind of think as these technologies become more publicly accessible and publicly used, that I feel like within 5 to 10 years, we'll have places kind of like Kinko's. We do have print houses now, that's without question. But the thing regularly accessible, like in towns where you can literally mail or drop your thumb drive off, and essentially things can be, created that way. But that is the obstruction right now. And there's been a lot of talk today, or at the conference, which I think is good, is like how do we kind of put this into our educational system? And I mean, it's tricky. And I heard people say, well, I'm just ceramics professor, like who's going to teach this stuff? And the truth is you are. I mean, if you want, I will say this, if you're in grad school and you're hoping to get a teaching job out of here, 2 things you better do is make good work, well, 3 things, show good work, and you better know these technologies, right? If you don't, I mean, I don't know many job interviews right now where they're not asking you about your knowledge of this stuff. When I came out of school, I was fortunate enough, the one thing I had going for me was that I had the ability to work in some other media and make some molds of other media. So that was like something that schools were looking for. That helped me out. But I mean, this is that thing now, right? You really need to know that. Good question?
Yeah, I was wondering if in medium you can set gravity, or if you can figure out like what the materials and the specifications, or if you have to do all that sort of testing of something in Rhino. Like when you mentioned making a big, larger scale piece, I'm just wondering structurally if they can run specs on it.
The question is, we should repeat. The question is, through Oculus Medium, can we essentially run specs with regards to materials, inherently gravity, because it's a gravity-free environment? And I'll defer to MacArthur on that for sure.
I'm not sure. I think I picked up part of it. And well, first of all, in an Oculus Medium, you can't simulate gravity or anything like that. It's you're just sort of direct sculpting. But you were also, it sounded like you were also talking about, like, maybe you're talking about like structural integrity of a particular material. You can do that in Rhino. So I haven't done it, so I'm not as familiar with it. But I know you can run some simulations from there.
It definitely is one of the limitations. I mean, I will say this about the medium, is they've changed a lot of things, and they tend to be regularly updating it. Like, initially it may have seemed almost like a kind of a gimmicky kind of making toy, but I think it's becoming really, but there are people you know, in industry, toy industry, I would say, who are actually starting to make them things for output. So they recognize that people are actually using this for a rendering software for rendering, you know, objects. So I think hopefully that will continue to grow, because it would be nice, honestly, to think about, yeah, some of those constraints in there.
Mm-hmm. So as soon as I got on here, I realized that I did not think this through. Because basically I was going to switch over to ZBrush, because what I was doing is I was laying this out and cutting it up in ZBrush, organizing it in ZBrush. But so now I'm actually doing it in Rhino, because ZBrush is on neither one of these computers. It's on my Mac. But the thing is, it's still geometry that can be imported directly into Rhino in this case, so you could skip it. And one of the things about CNC routing, it's actually pretty forgiving in terms of the geometry. So whereas you do have to worry about holes and other things with 3D printing quite a bit and make sure that it's just right, there are no internal forms. Using with the CNC routing, it can actually just look at the surface and cut from there. And so what I'm going to do, so usually I would align things in there. Here I'd have to do a little bit more to get this. It'd take me a few more minutes to get this set up. So what I'm going to do is I'm just going to lay it down and make a parting plane. And
that's a really ugly piece, by the way. I apologize. Did you have a question?
Yeah. I'm curious. This virtual sandbox is amazing to work with, and I haven't experimented with it, but I feel like I learned how to make stuff on the wheel.
Yeah. Right.
I work on the CNC mill, and I've tried to use longer bits to carve deeper forms. The problem that I ran into is the spindle speed and the feed rate, and the kind of texture that it creates because of what you choose.
Yes.
Because they have standards for 1.5 bits. Did you have any experience with changing that and any success in figuring out what texture?
We did mess with that a good bit, and I noticed that we definitely had a variation with the kind of cutting on some of the larger bits. I wanted, because of the width and the speed, that simply going from this bit to this larger hogging bits, the speed on the edge of that larger bit is going to be faster. I wondered if that was the difference, but you can probably address that more.
Oh gosh, I missed part of it.
Sorry, I'm giving it to him. I'm throwing it all on him at the same time. We did experiment with it. I can tell you that. He can answer me more specifically.
But with the bits, you're saying you were having a problem with the speeds and feeds because of the depth of it, though?
Did you think the longer bit was the issue?
The longer bit toward the plaster, I was carving plaster.
Okay.
Oh.
Huh.
And so then it was just about varying the speed, and I'd already given the direction, so my mold did not come out with the same texture.
Yeah.
Oh, no, I hadn't seen that. But yeah, I haven't been cutting plaster, but I hadn't had that issue. I'm actually surprised that happened. It seems like if it's the same speed, it will work. Except that if it's a longer bit, maybe there's some deflection. It can kind of move move, especially on a hard material like that, back and forth, which might actually, the chatter from that alone actually might cause a problem. I could see that, and then you'd have to probably. I'm not sure if doing it slower. Well, I mean, maybe running it slower would help, but I imagine that would be pretty difficult anyway with that.
Yeah, I slowed
Yeah.
down and I got
It was smoother.
sets carved out with a little bit of texture in those carved contours. And I
Okay.
liked that. But
Yeah.
I was curious if they had any.
No, and that was one of the reasons. So we don't cut plaster on there, and actually that's one of the reasons why I like the foam. But in terms of the surface quality, it's not as great. I mean, I know they have like tooling boards, which I think I'm going to switch and do this differently. But they have tooling boards that that have a really fine texture, but they're so expensive. That's the only thing. So we were kind of looking at MDF too as another option for it. Like tooling board is just foam. It's really dense foam, but the pricing on it is out there.
Yeah, I want to look into casting my own foam possibly, and then so I can customize it. I worked a good bit with foams, but obviously not. I mean, whether I can produce it with the same kind of consistency that would be the case. But other people use the floral foam. People speak very highly about that. It's very soft, but not the wet floral foam, but the dry. But even that's relatively expensive, you know. But I heard people rave about that, but I haven't tried it yet.
So, yeah, so I'm going to try to do this in a really crude way. I'm just going to go ahead and make a surface, and there are faster ways. My main software is more, so Rhino I've been using just for this more recently, but I'm making a rectangle here, and then I'm going to cap that rectangle to fill it in. No, planar. Actually, I want a planar surface. So in Rhino, you often type in commands. So I'm going to type planar surface in there. So if I go back to this view, you can see I have this plane here that I can move throughout the surface. Whoops, actually I have this curve here, and I have the plane. I can delete that. But so now I can kind of figure out how I'm going to place this. Now, of course, in looking at this, you can see that undercuts like this are not going to come out. That would take a lot. Well, first of all, you may just avoid the undercut, or you may have to engineer something for it. But this is really, you just want to do a very simple sort of test of this. So I'm going to take this. I could measure it out. I guess that's probably really helpful at this point. Yeah, I didn't. Now that I'm thinking about this, I don't know what these units are in Rhino, but that's okay. So what I can do is I can go to dimension, linear dimension right here, and I can click from point to point and draw out something. So this is actually huge. So and I'm assuming, yeah, this is huge. So I'm going to dimension this one also, and I'll shrink this down. So yeah.
I have no idea what he's talking about, by the way.
So well.
But this is honestly, I mean, but this is you know, and it's something that I need to learn. I mean, this, you know, we have these great thing. USF, we have these seats on the lynda.com, you know, which is this great kind of like learning sites, and so that's, you know, that'll be summer, right? And trying to learn this stuff. Again, I don't expect to ever have the expertise or knowledge that he does. We are fortunate we have a technician who can assist with these things. But this comes to the other question, which is kind of like next steps. And as these technologies enter our programs, you know, it's the financial side of it, not only with regard to the equipment and how you acquire those fees, how you purchase the equipment, but then, you know, they really need to be staffed. And that's where it gets tricky, because a lot of these schools, I mean, ours too, I mean, we need a full-time person in there all day, right? And it's, I mean, to really kind of get this kind of learning happening. And then how we incorporate it into our classes, I mean, we're still kind of figuring that out. I mean, so the toys class was one way, but even that, the students are in the class, it's like it's a lot of technical information to learn, to pack into a single semester. But we're not a university that really does a lot of skill acquisition type classes, right? We don't do necessarily ZBrush 1, ZBrush 2, nor do I typically do, you know, I don't really have much of a linear, I teach ceramics, but it's difficult for me to even have kind of a linear trajectory in ceramics, right? We have like more transfers than maybe almost any university in the nation. And so people are coming in at different levels. You know, the great thing is we have an amazing, they're coming to us from an amazing system of community colleges who have great, you know, and that's amazing. The kids come in knowing a lot about clay. But yeah, we're figuring it out as well, and kind of where it's going to go. But I mean, next steps for us, yeah, kind of figuring that out more, incorporating, having classes that ultimately are simply about VR sculpting and outputting.
Mm-hmm.
And we now have several headsets coming in. We have more. I don't know how many we'll have. By fall, we'll probably have, I don't know, maybe 8 or 9. I can't remember.
But the other thing is, like, in terms of sort of interdisciplinary relations. Well, actually, yeah. So I teach animation and digital modeling. So the digital modeling students do have courses like it's like a ZBrush
You do,
focus.
yeah. They do more than we do.
And then we also have like a digital fabrication course, which is really meant for students who are sort of working within animation modeling or any of those areas, but also sculpture as well. So there's that opportunity to kind of cross over, and I also think like that course, like the toys course, kind of offered that too.
And being at a research school is great. Obviously, we have a lot of crossover with other programs, including engineering. One of our students, Tina Parachi, built a polar style extrusion printer, but teamed with some people from engineering for that. So you know, there's a lot of things kind of happening that, you know, it's great to kind of, you know, the way things kind of bleed across at a university like ours.
So what I did is I brought this into Aspire, this file into here. And actually, if you have any questions at any point, let me know. So, and what I'm just doing is orienting it, and then I'm going to center it in this area here, which is actually the block of material. So I'll just center that model. So I've exported it right out of Rhino. And now it's fitting in there. Now this is way too large for this, and so I'll have to push this down. I mean, like I said, the scaling of it, I hadn't gone through this. I didn't know what I was getting, and then I also imported this at a weird scale. So I guess I could. I'm not going to scale it now. So what I can do is pull this down in depth. So it's only going to get part of this. Well, maybe I can still get. I'm going to go above it and maybe here. So and then just click OK. It's really rough. So now it's in there, but what I don't have is a tool path for it, which tells it how it's going to cut it. So if I go over to, in here, and this is without setting up a lot, you have two things for carving out things like this. So you have a roughing pass and a finishing pass. So if I click on a roughing pass for the tools, it'll give me something like this. Now the model is way too big, so I'd have to shrink it down, which is part of the issue here. Before I was measuring stuff way out before, and this is way too big. So I wanted to see if I could force it somehow that would allow me to do this, but it's not.
Error.
So I will see. Maybe I can. Let me try that again. Let me just say 5. Well, let's just do file new. Oh yeah. Well, I mean, yeah, it wouldn't fit the. Yeah, you're right.
Yeah, we're working
right.
it to his specs of our machine, but you're right.
Yeah. Like so let's see if I. Let's say I had a. This is not where I would do that actually. Here we go. Set thickness. I don't know, 7 inches. It's crazy. I don't know if I would actually have that. And then it looks happy. So yeah, and let's just try. I know this would not work, but so anyway, here let's try a roughing pass. I could never use this bit, but let's see, 1/2 inch. I'm just gonna go with it and see what happens. Calculate. Okay, so it did make something. So the nice thing about this is you can actually preview what this looks like. So you can click preview selected toolpath, and you can actually see it carving that roughing pass. And I can go back in and create another pass here. This will be the last one. So in this case, I'm going to do a finishing pass and say calculate. And it'll give me a much more detailed one. And actually, that's a really tight bit. So I'm going to go to preview all toolpaths, and then you can see what it will look like carved in to it. And then you can basically save out a file. Let's call it tap file that goes to your CNC router. And I'll stop there.
And I guess we're out of time.
Yeah.
We could be glad to answer any questions. Oh, yes, sir. Yeah. Well, the Oculus itself is not that expensive. Well, I mean, it's about $400.
Yeah.
The trick is the computer to run it.
Yeah.
And I mean, you probably get a desktop to run it for, you can scrape through under a couple grand, but obviously some of these ones that are really doing it well. I mean, I have one that's not probably as fancy as it could be, and I have some limitations in terms of how much resolutions I can snap down to. But yeah, whole setup for easily for under 3 grand. I mean,
That's what. Yeah, the computer is the biggest part of that. Yeah.
But yeah, the Oculus is about 400.
I don't know what the source. Yes. Mm-hmm. You said, can you do this?
More than 2, yeah. Can you
Oh
use it?
yeah,
Yes.
actually yeah. You can. In Rhino, it's really great for that. I haven't done much more than the 2-piece molds. I'm interested in doing that, but also, I mean, I've seen people do it. I mentioned like Del Haro. He's created some really complex. I think I saw like a 4 or 5 part mold he made. Yeah, which is and cutting in it. But the thing is, it's really great because you can totally engineer it in the software. So and kind of test it out and see exactly how it's going to cut. Yeah. Yes.
Did you experience any physical effects from spending extended time in VR, nausea or
No, it's a valid question though, because I'm not one that can play like certain types of, like, shall we say, first-person shooter games where you're moving. And it's strange because I think that it's my movement that's controlling what the vision is. But there is one particular kind of experience. They call these things. Oculus has a lot of different programs. Some of them are games. They call them experiences. But there are a couple there that definitely no. But this thing I haven't had an issue because again, it's moving where I'm looking and it's doing it quickly. There's no real lag. And if there were that, I could see that being an issue. But yeah.
Yeah, usually it's from a disconnect between like what you're doing and what the software is doing. Like if you're floating somewhere, going through space, but you know that that's not happening. That's
There's
where
a
that
game
happens.
where you're in a spaceship and I can't do it. No, not happening.
Yeah, but these are all your movements, so it's fine. It's fine. Now the only thing is it does have a little bit of weight on it. So over time, I think just I can feel that, like whether it's my back or neck or something like that. And sometimes I'll sit down, sometimes I'll stand up and work around. I just take breaks. That's it.
Yeah, I tend to work sitting down just as I would in my studio. And I'll even, for instance, like when I'm working in my studio, I have a table that I up and down lift, but I'm putting my elbows on there, if I want to do tight detail work, and I'll do the same with this. And so it takes the weight off it. I mean, it's maintain my stability with regards to my elbows on a surface, and I'll work that way.
Let's try that.
Yeah, it's great. Yes.
Just wondering, like outside of the classroom, what are the best resources for finding information about these programs, and also like working from one program to the next, like the workflow?
I guess from one program to the next, I'm not sure if I've seen a lot of stuff for that. I mean, in like, for instance, like I said, I could probably do that thing in ZBrush, like, and go through the whole process in it. Or you could actually just go through Rhino. I mean, I'm saying that because it's kind of everybody sort of figuring out their own way and with the tools that they have. But a lot of this stuff is really, really well documented. I mean, in terms of using the software itself, like for instance, like I said, Rhino, you could actually go to DataClay and look at his stuff on parting planes, but also YouTube. Well, YouTube will give you more general information on using Rhino, and you can kind of find scripts and whatever else if you need. And ZBrush as well. It's just tons of stuff on YouTube. There's lynda.com. There's all kinds of resources out there. And if you go to their websites, they all have, I don't know about how extensive Rhino's is, but like ZBrush's and several of the others, you can find stuff.
Yeah, Rhino often is, if you're still in school, Rhino often has the training sessions, because obviously they want you to be integrated with their kind of software. So you get on their emailing list, a lot of times they'll come. But for students, the software is relatively, like $100 maybe, it's quite inexpensive.
Yeah, pretty much.
And then they'll do weekend training sessions, which I need to do because honestly, I get lost. I got a lot to learn.
But the thing is, once you learn one software and you're working with it, it's easy to kind of, then you can kind of make connections. That's the thing. So and that's exactly how it happens. I would say, oh man, I could actually just jump over to Rhino to do this because I know it has this function, and back and forth. But it's easier to probably just start with one unless you're following a specific workflow. You're saying, yeah.
Anything else?
All right. Anybody else?
All right. Thank you very much.
Thank you.
Appreciate it.